Okay, Assalamualaikum warahmatullahi wabarakatuh. Uh, Hello to all my friends and my beloved teacher. Okay, now I will introduce about BJT. Okay, in this video, I will be discussing practical work 3, which focus on bipolar junction transistor or BJT. BJT are one of the most important and widely used in semiconductor device in the field of electronics. They play a crucial role in various applications such as signal amplification, switching and digital logic circuits. Their ability to control a large current using a much smaller input current makes them fundamental components in both analog and digital electronics. The BJT was invented in the late 1940s and revolutionized the electronic industry by replacing bulky vacuum tubes. Today, BJTs are found in everything from radios and television to computers and industrial control system. Understanding how BJT works help in designing and analyzing more complex circuits, especially in areas like power electronic, communication system and embedded system. Okay, now we go through to BJT terminal and function. Okay, bipolar junction transistor BJT is made up of 3 terminals: the base, the collector and the emitter. Each of these terminals plays a crucial role in how the transistor operates, particularly in terms of controlling current flow. Okay, first, the base is the central terminal and acts as the gatekeeper of the transistor. It is very thin and lightly doped, which means it has fewer charge carriers compared to the emitter and collector. The base main function is to control how many charge carriers, electrons or holes are allowed to pass from the emitter to the collector. A small amount of current entering the base controls a much larger current flowing between the collector and emitter. This current control allows the transistor to function as an amplifier or switch. Okay, second, the collector is the terminal that collects the charge carriers after they pass through the base. It is moderately doped and larger in size to handle the head current. In an NPN transistor, current flows from the collector to the emitter and electrons as charge carrier move from the emitter to the collector. In a PNP transistor, the direction is reversed. Current flows from the emitter to the collector, and holes are the majority charge carriers. And the third is the emitter. It's heavily doped to supply a high concentration of charge carrier. It emits carriers into the base region. In an NPN transistor, electrons are emitted by the emitter into the base and then pulled toward to collector. In a PNP transistor, holes are emitted from the emitter into the base and move toward the collector. Okay. For a BJT to operate correctly, the base emitter junction must be forward biased and the base collector junction must be reverse biased. This means the voltage at the base must be higher than the emitter in NPN or lower in PNP, and the collector must be more positive than the base NPN or more negative in PNP. Under these conditions, a small base current allows a larger current to flow the collector to emitter in NPN or emitter to collector in PNP. Thus, The base terminal effectively controls the current flowing through the other two terminals, making the BJT a current control device. Okay, next for our third. Okay, now I will explain about BJT types. Okay, there are two main types of bipolar junction transistor, which is NPN and PNP. The main difference between them is the direction in which current flows and how they are connected in a circuit. Okay, in an NPN transistor, the current flows from the collector to the emitter, and a small current flow into the base to turn the resistor on. For it to work properly, the base must be more positive than the emitter, and the collector must be more positive than the base. This setup allows electrons to move easily from the emitter to the collector, controlled by the base. Okay, in a PNP transistor, the current flows in the opposite direction from the emitter to the collector. To turn it on, a small current must flow out of the base. In this case, the base must be more negative than the emitter, and the collector must be more negative than the base. Holes instead of electrons are the main carriers in a PNP transistor. In simple terms, NPN transistor turn on when the base gets a positive signal, while PNP transistor turn on when the base gets a negative signal, even though they work in the opposite ways. Both types are used to control current in circuit depending on the design. Okay, at my back you can see that the difference between NPN and PNP. Okay, now we do the experiment, identify an NPN and PNP. Okay, first identify base. We do 0 ohm adjustment, divide by 100. Okay, until the scale at 0. Okay, next we put the red probe and black probe to the transistor until we found the base. Okay, now we found the base. The scale is moving. Okay, next we identify the NPN or PNP. Okay, 0 ohm adjustment. Okay, low accuracy and low. Okay, so that the NPN. We continue to BJT materials. Okay, bipolar junction transistor BJT are made using semiconductor materials, which are essential for controlling the flow of electric current. The most common materials used in BJT are silicon, as known as Si, and germanium, as known as Ge. In the early days of transistor development, germanium was widely used because it allows current to flow easily due to its high electron mobility. However, germanium has some limitation. It is less stable at high temperature, and it is more sensitive to leakage current, which can affect the performance of a circuit. Today, silicon has become the most commonly used material for BJT, and for good reason. One of the biggest advantages of silicon is its thermal stability. Silicon transistors can operate the higher temperature without being damaged, making them much more reliable in different environmental conditions. Additionally, silicon has better electrical properties for most applications, such as lower leakage current and higher breakdown voltage, which means it can handle higher voltage without falling. Okay, now we go to experiment how to identify silicon aluminum. Okay, first we find the collector and emitter. Okay, do zero adjustment at divide by 10k. Okay, put the black probe to base and red probe to another 2 point. Okay, next identify the silicon or germanium. Okay, we go back to divide by 10, divide by 100, and we do 0 ohm adjustment. Okay, this is how to identify silicon or germanium. Okay, put that 2 probe at another point, not at base. Okay, now we know that the silicon. Alright. Conclusion. Through this experiment, we gain a clear understanding of how bipolar junction transistor BJT function, starting with the roles of its terminal, the base, collector and emitter. We observe how a small current applied at the base is able to control a much larger current flowing between the collector and emitter, which is the key operating principle of BJT. This makes them highly useful in both amplification and switching application. We also study the two main types of BJT, which is NPN and PNP, and compare their difference in terms of current flow direction, biasing condition, and charge carriers. NPN transistor use electrons as the main carriers and turn on with a positive base voltage, while PNP transistor use holes and turn on with a negative base voltage. In addition, we explore the semiconductor materials used to build BJT, especially silicon and germanium. While germanium was commonly used in early transistor design, silicon is now the preferred material due to its higher terminal stability, lower leakage current, stronger electrical performance and abundance, which makes it more cost effective for mass production. Understanding the structure, operation and materials composition of BJT is essential for anyone working in electronic or electrical engineering. Proper knowledge of how to identify and connect the terminal, how to choose between NPN and PNP, and what material perform best under different conditions can greatly impact the performance, safety, and efficiency of a circuit. BJTs are found in countless electronic devices, from small signal amplifiers in audio equipment to high-speed switching circuits in digital systems. Without a clear understanding of how BJT works, it's difficult to design reliable and optimized circuits. This experiment not only gave us hands-on experience but also built a strong foundation for applying BJT concept in real-world electronic designs. Okay, it's all from me. Thank you.